Welcome back. Today we will see some of the standard integrals using by parts. Now, to evaluate the integrals of the type sine inverse of x, tan inverse of x, sec inverse of x, log of x, we take the second function v as 1 and then we apply the theorem by parts to evaluate these type of integrals. Let us study the standard integrals using the by parts. The first one is integration of root a square minus x square dx is given by x upon 2 root a square minus x square plus a square upon 2 sine inverse of x by a plus c. The second one is integration of root a square plus x square dx is equal to x upon 2 root x square plus a square upon 2 log of x plus root x square plus a square plus c. The next one is root x square minus a square. Its integral is given by x upon 2 root x square minus a square upon 2 log of x plus root x square minus a square plus c. These are the three important formulae for which we will going to derive from the theorem by parts. And many times these are asked in the board exam for 4 marks. Let us prove the first one. Integration of root a square minus x square dx is x by 2 root a square minus x square plus a square by 2 sine inverse of x by a plus c. Let I is equal to integration of root a square minus x square into 1 dx. So for to apply the by parts, there we must have two functions. So this is the first function and the second function is 1. So use by parts first function as it is integration of the second function minus integration of the bracket derivative of the first function into integration of the second function. Now integration of 1 is x and derivative of root a square minus x square is 1 upon 2 root a square minus x square into derivative of this a square minus x square, that is minus 2x. Here we are using actually root f of x, chain rule. Root f of x, its derivative is given by 1 upon 2 root f of x into f dash of x. So 2 will get cancelled and you get root a square minus x square into x plus integration of x square upon root a square minus x square dx. So in next step, what we will do, just add and subtract a square. We will add and subtract a square so that after dividing this root to each of these integrals, numerator a square upon root a square minus x square minus a square minus x square upon root a square minus x square dx. So here a square is a constant, so we can take outside the integral, and here you will get one root a square minus x square after simplifying, because I can write this root a square minus x square as root a square minus x square bracket square. So one of the root will cancel to this denominator, but it is nothing but our given integral I. So I will replace it by I. So minus I. This minus I will come to this side and you will get 2I. And at the same time, integration of 1 upon root a square minus x square, its integral is given by sine inverse of x by a plus c. Now we will divide this by this 2. You will get I is equal to x upon 2 root a square minus x square plus a square by 2 sine inverse of x by a plus c. Therefore, integration of root a square minus x square dx is equal to x upon 2 root a square minus x square plus a square by 2 sine inverse of x by a plus c. So what is the integral? Then root 9 minus x square. This is the example which will based on this formula. 9 means 3 square. So 3 square minus x square, its integral is given by x by 2 root 3 square minus x square, that is 9 minus x square plus 3 square upon 2 sine inverse of x by 3. But 3 square is nothing but 9. So 9 upon 2 sine inverse of x by 3 plus c. This is the way to use the formula in solving the examples. Now this is the next proof. Root a square plus x square, its integral is given by integration of root a square plus x square into 1 dx. Okay, so what you will get, I is equal to integration of root a square plus x square into 1 dx. So first function as it is, integration of the second minus integration of, in bracket, integration of 1 dx into d by dx of root a square plus x square. Its derivative is given by 1 upon 2 root a square plus x square into 2x. This x and this x, you will get 2x square, but the 2 and this 2 will cancel to each other, and you will get x square upon root x square plus a square plus x square. Now in numerator we will add a square and subtract a square, and after that we will divide this root a square plus x square to these two terms. This from this, the first after simplify this x square plus a square upon root a square plus x square, you will get root a square plus x square only, and here is a square upon root a square plus x square. A square is a constant, so we can take it outside the integral, and this is nothing but our original integral I, so we can put I here. 1 upon root a square plus x square, its integral is given by log of x plus root a square plus x square plus c1. Now this I will come to this side, you will get 2I. So 2I is equal to x root x square. I is equal to I plus I is 2I. So 2I is equal to x root a square plus x square plus a square log of modulus of x plus root a square plus x square plus c1. Now we will divide this right hand side by this 2. You will get I is equal to x upon 2 root a square plus x square plus a square upon 2 log of modulus of x plus root a square plus x square plus c, where c is c1 upon 2. So this is the proof of the second integral. Now moving further, this is the third theorem. I is equal to integration of root x square minus a square dx. For this also we will choose the second function as 1. Okay, then using by parts. So first function as it is, integration of the second function minus integration of bracket integration of the first function into dy dx of the second function. So first function as it is, into integration of 1 is x, integration of 1 dx is x, dy dx of root x square minus a square is 1 upon 2 root x square minus a square into 2x. So 2 will get cancelled, and you will get x square upon root x square minus a square. Now next step here, I will subtract a square and add a square. So x square minus a square plus a square. I will just group these x square minus a square and divide it by root x square minus a square plus a square upon root x square minus a square. Separate the integral, at the same time simplify this first. You will get here root x square minus a square. Okay, but this is our integral I, so I can replace it by I. Here the 1 upon integration of 1 upon root x square minus a square, its integral is given by log of x plus root x square minus a square plus c1, constant of integration. Minus I will go to that side, and here it becomes 2I is equal to, then we will divide this equation by 2. So we get I is equal to x by 2 root x square minus a square minus a square upon 2 log of x plus root x square minus a square plus c, where c is c1 upon 2. Now this is the next example, x sine inverse of x dx. I is equal to sine inverse of x into x, because here I am using the LIATE rule: logarithmic function, inverse trigonometric function, algebraic function, trigonometric function, and exponential function. The sequence must be like this. So first function must be an inverse trigonometry. So I have taken the inverse of x. So first function as it is, integration of the second function minus integration of derivative of the first function into integration of the second function. Now integration of x is x square upon 2, and derivative of sine inverse of x is 1 upon root 1 minus x square. So from in this integral, I can take 1 upon 2 common. Then what will remain? X square upon root 1 minus x square. So I will take this minus sign to here, and I will write here plus. Then I will add 1 and subtract 1. So 1 minus x square minus 1 upon root 1 minus x square. Now I will divide this numerator separately by this root. Then here I will get integration of root 1 minus x square dx minus 1 upon 2 integration of 1 upon root 1 minus x square. Now here I will use one of the formula that we have studied earlier. Uh, root 1 minus x square, its integral is given by x by 2 root 1 minus x square plus 1 upon 2 sin inverse of x. And here the integral 1 upon root 1 minus x square, its integral is given by 1 upon 2 sin inverse of x plus c. Just multiply this bracket by this 1 upon 2, you will get x upon 4 root 1 minus x square minus 1 upon 4 sin inverse of x. So in next step, this x square upon 2 sin inverse of x plus x by 4 root 1 minus x square x sin inverse of x. Its integral is given by x square by 2 sin inverse of x plus x upon 4 root 1 minus x square minus 1 upon 4 sin inverse of x plus c. Now cos inverse of root x, we want to find its integration. Now here there is no product of two functions, but here there is a composite function root cos inverse of root x dx. Now has we have to substitute root x is equal to t to evaluate this integral. So root x is equal to t implies 1 upon 2 root x dx is dt. So dx is equal to 2 root x dt. But root x is nothing but t. So I get 2t dt. Replace. So the given integral becomes cos inverse of t into 2t dt. So it is already in the form of LIAT rule. So first function as it is, integration of the second function. Okay. The integration of the 2t is 2t square upon 2. Then derivative of the first function into integration of the second function. So I is equal to cos inverse of t into t square minus integration of minus 1 upon root 1 minus t square. It is the derivative of cos inverse of t. And the integration of 2t is 2t square upon 2. So t square cos inverse of t minus integration of in bracket minus t square upon root 1 minus t square dt. So here I will add 1 and subtract 1. So this is an adjustment only, so that I can divide this numerator by this denominator separately. So here I will get root 1 minus t square plus integration of 1 upon root 1 minus t square. So here I will get the integration sin inverse of t, and here you have to use the formula integration of 1 upon a square minus x square is given by x by 2 root a square minus x square plus sin in 1 by 2 sin inverse of t. So t square cos inverse of t minus t upon 2 root 1 minus t square minus 1 upon 2 sin inverse of t plus sin inverse of t plus c. So add and subtract these two, you will get 1 upon 2 sin inverse of t plus c. But what is t? Already we have substituted for t, root x. So root x, its a square is t square. So whenever there is a t square, I will write it here x, and the t is replaced by root x. So I is equal to x cos inverse of root x minus root x upon 2 root 1 minus x plus 1 upon 2 sin inverse of root x plus c. Now look at this example, root 4 plus 3x minus 2x square dx. So it is in the form of root of the quadratic factor. So here we have to make the perfect square. Before that, we must take 2 common from the square root, so that I write it as square root of 2 times root 2 minus x square minus 3 by 2x. Now how to find the last term? Last term is obtained by 1 upon 2. I will write here 1 upon 2, then coefficient of x bracket square 1 upon 2 coefficient of x bracket square. By this formula you will get the last term. How? Minus 3 by 2 into 1 upon 2 is minus 3 by 4 and its square is 9 by 4. So we have to add 9 by 6, 9, sorry, 9 by 16. 1 upon 2 times coefficient of x bracket square. So 1 upon 2 into minus 3 by 2 is minus 3 by 4 and its square is 9 by 16. So this is our last term that we are going to add and subtract. Okay. So 2 plus 9 by 16 and minus x square minus 3 by 2x plus 9 by 16. Now this bracket is nothing but x minus 3 by 4 bracket square. And here you will get root 41 upon 4 bracket square. So this, after simplification, you will reach at the stage where you can apply the formula root a square minus x square. Look at this formula. Just now I have told you to use root a square minus x square. Its integral is given by x upon 2 root a square minus x square plus a square by 2 into plus a square by 2 sin inverse of x by a plus c. So use this formula here. You will get root 2 into in bracket x minus 3 by 4 upon 2 root 41 by 4 bracket square minus bracket x minus 3 by 4 bracket square plus root 41 upon 4 bracket square upon 2 bracket x minus 3 by 4 upon root 41 upon 4 plus. So simplify this, you will get a 4x minus 3 upon 8 root of 2 plus 2 3 by 2x minus x square plus 41 upon 252 into 4x minus root 3 root 2 in bracket 4x minus 3 upon 8 square root of 2 plus 3 by 2x minus x square plus 41 upon 32 sin inverse of 4x minus 3 upon root 41 plus multiply this bracket by this root 2, or you can keep it as it is. This is your answer. Okay, now we'll stop here.